All right. So as we graph AB, A is -3, 0. Where's that? On the let's see. On the what? X-axis. Good. Left of the origin 3. Where's B? 3, 0. On the x-axis to the right 3. So draw a triangle ABC so that C lies on the y-axis. How many of you put C on the y-axis above the origin? How many of you put C on the y-axis below the origin? Okay, that's fine. Either one's fine. Let's take a look. That's where this book puts it. How would you classify this triangle by its side lengths? Skinny, isosceles, equilateral. I hear isosceles. Some people, you have equilateral? Mm-hmm. How do you know? Good. McKenna?
What?
Did she steal it? Did she steal your answer?
Sure, yeah.
What were you going to say?
I don't know.
Oh, why'd you have your hand up?
Because I thought I knew.
Oh.
And then I don't think first sounded like what I was going to say. The distance formula.
Distance formula? Do you agree we all know the length from A to B? Everybody's picture A to B is the same. What's A to B? 6. Good. Now, depending on where you put C, could it be scalene? Could that triangle be scalene? If C is on the y-axis? No. Could it be isosceles? Could it be equilateral? Yeah. And you would have to find the distance from A to C and B to C. We know these two are congruent. We just don't know if they're congruent to 6. Agree? So you would do the distance formula. What's this point? -3, 0. What's this point? 0, 2. Anybody have 0, 3? Anybody have 0, 5? I mean, 0, comma, let's call point C 0, comma, K. We're going to make up a letter. I don't care what letter it is, other than A, B, or C. Call it K, call it M, I don't know. And you would have to use the distance formula from 0K to -3, 0. And then 0K to 3, 0. And find out what K would have to be to make it equilateral. Right now, it's just isosceles. Could be equilateral. All right. Repeat parts A and B, drawing C at different points. All right. Then you guys had some different examples of that. And we just talked about whether it is isosceles or not. Now, we could prove this is isosceles. Do you agree in this right here? I did not put 0, 2. I did not put 0, 3. I called it 0, comma, K. And then we would do the distance formula from here to here and here to here and show that with K, they are the same length. You understand that? You guys want to do it? No? We can move on. Okay. Can you accept that, or do you need to see that? That you would do the distance formula with K in it, and you get an answer with K in it. You're not going to get a number. Tally?
I don't really understand.
Thank you for being honest. I'll do it quickly, because this is going to be the foundation of our lesson. So might as well. All right, ready? So I said it's isosceles, but I don't know that we should just trust that. Let's show it. So A to C, distance formula. Ready? AC. We'll do it in blue. 0 minus -3 squared plus K minus 0 squared. Make sense? 3 squared, 9. 9 plus K squared. Do you agree? 9 plus K squared.
What if you're not subtracting it by 0?
Well, we put it on the x-axis, so it had to be.
No, but like, what if it was a different thing?
Yeah, it was like K plus 4 squared, something like that. Yeah, get ugly. All right, now let's do the other one in green. Same length, we say isosceles. Different lengths, we don't know. All right, let's call it BC. Ready? 0 minus, well, this point is 3 comma 0. 0 minus 3 squared plus k minus 0 squared. What's negative 3 squared? 9 plus k squared. Same like?
Yeah.
Yes, isosceles. Now here's what's really cool. If I wanted to make this, it's already isosceles. If I want to make it equilateral, how would you find that? How would you find the value of k that makes it equilateral? Make me proud. I know it's early. It's a long weekend.
What did you say?
How would you find the value of k that would make it equilateral? So, what do these things mean? What do these mean? They are the length, the distance, the length of those segments. If we want it to be equilateral, what do we want the length of those segments to be?
The same.
Not just the same. We know what it needs to be. 6. Are you with me?
Oh, it has
This is the fixed one. What is it? 6. Everyone else's people put C different places. But everybody had a bottom segment of 6.
It has to be
So wouldn't you set this length equal to 6? Isn't this the length of the segments?
Yes.
How would you solve that?
Minus.
What'd you do first? How do you we want to get k by itself.
Subtract 9.
Can't yet. There's a square root there.
Oh, take away the square root.
How do you do that? Square both sides. Squaring gets rid of square roots. Do you agree? Do you know that? Squaring gets rid of square roots. So 9 plus k squared equals 36. Minus 9. What's 36 minus 9? Good. Square root. K is the square root of 27. 9 times, break it up. 9 times 3. 3 times 3 times 3. K is 3 radical 3 in square root form, or a little more than 5 in decimal form. So what does that mean? 0, comma, a little more than 5 would be where point K or C needs to be to make this triangle equilateral. That's kind of cool, right? Oh, come on. You guys are in honors math. If you want to continue on with honors math, you just start to appreciate stuff like that. That's cool. Oh, we're having murmurs of not liking math anymore. All right. You'll find out the farther you go in math, the less numbers you have and the more variables you have. All right. I took a whole class and approved class in college that there were no numbers, all letters, like a different language. All right. When I made this, I kind of your graph's a little different than mine. That's on purpose. Place each figure in a coordinate plane in a way that is convenient for finding side lengths. This is weird. This whole section is called coordinate proofs. Coordinate means on the XY axis. You're going to need graph paper for homework tonight. I provided all the graphs in the notes. So place each figure in a coordinate plane in a way that is convenient for finding side lengths. Do you agree? Do you agree this triangle was placed conveniently to find side lengths? What does that mean?
It was easy to find something.
Yeah, because what if they did this to us? Watch this. What if they said, What if they gave us the triangle like that? That would be mean.
I wouldn't do it.
Because guess what? You don't count to find that. Oh, that's 6. That's easy. 6. You'd have to use the distance formula. Do you agree that'd be really messy? So when we say place each figure in a coordinate plane in a way that is convenient, what does it mean by convenient? Like, let's say the rectangle. What would be a convenient way to place a rectangle on a graph?
Oh, yeah.
Okay, what do you think?
Putting it on all like the lines.
Yeah, put it on the axis, right? So maybe a point there. Yes.
Okay.
A point there. A point here and a point here. Do you agree using both axes would be a convenient way to place this rectangle? Why is that? Well, you have made some of the values in those points 0. Now, I'll be consistent with the book. Okay, this point is called obviously 0, 0. But the other points depend on the lengths of the sides. I didn't make that square, did I? 1, 2, 3, 4, 5, 6, 7. 1, 2, 6. Okay, mine's 7 by 8, but it's in general. Yours might be different. That's okay. Don't make yours the same. You don't have to. Because guess what we're going to do? We're going to generalize these points. They call the length of we would call it the height of this as K. And they call the length of the rectangle H. So this rectangle is H by K units. We don't know what it is. We don't know if it's 4 by 8, 5 by 7. I just drew it up here, but that doesn't mean it has to stay that way. All right, now if this length is K, who can raise their hand and tell me the coordinate up here in general? If the height of this rectangle is K, then this 0, okay, thank you. 0, comma, K. The X value is 0. The Y value is whatever length K is. It's K. All right, how about this point over here? Jared. H, comma, 0. And that makes this point up here. Who can raise their hand and tell me that one? Page. H, comma, K. And then last, they asked us to assign coordinates. So, we already assigned coordinates. I thought they meant assign names like A, B, C, D. Don't have to do that. Just coordinates. Yeah.
You have to have it in that order, like HK, or could it be KH?
Where would KH be?
It would be like the top of the.
See, our points always go X, comma, Y.
Yeah.
Isn't H the X length over? So H has to be the X. All right? That's it. That's it for that one. How about a triangle? McKenna?
Couldn't you do like a right triangle?
We could, but does it say it's right?
What does it not say?
It doesn't say.
It doesn't say it's not.
It just says a triangle.
So our logic is a little backwards. Okay? You can't narrow down something that's abstract. Okay? So did it say place a right triangle? No. So we don't get to choose. We don't get to narrow down and say, they said triangle, I'm just gonna make it right. Or I'm gonna make it isosceles. They said place a triangle. Do you get why that's kind of a backwards way of thinking? No.
I just, if it says place a triangle, it doesn't matter.
So you can't
put
place
a
any
triangle.
place in the triangle.
But here's the deal. If I say place a triangle, here's the umbrella of triangles. Like, think Venn diagram, okay? Do you understand? Levi, does that not make sense?
No.
Okay, so let's say you can be whatever you want to be. in life. Okay? After high school, you can do whatever you want to do. Ready? Actually, no, I'm going to choose for you. You're going to be an accountant. Okay?
I'm good. I'm not good at math.
No, you're going to be an accountant. I get to choose. Okay? Okay? I get to choose. Or does it go the other way around? Where, okay, we can do whatever we want. Let's narrow it down to whatever. See, I don't get to choose what you are, right? If I say you can be whatever you want to be, I don't get to choose. So if it says it can be any kind of triangle, you don't get to choose. Does that make sense? A general triangle.
But what if it just so happens?
What if it works out to be what exactly? Thank you. What if it works out to be a right triangle?
I'm just that good.
Okay.
Isn't that like the most convenient way? Because you can do two sides.
Sure. Sure. 0, 0. But here's the deal. I'm going to put over a point over here. I'm going to be consistent with the book. They call it D. We'll call it D also. Now, could you have called it M, comma 0? Sure. They called it D, comma 0. All right. Now, did it say it's a right triangle? Did it say it's isosceles? Did it say it's equilateral? No. So we're just going to create some points. And you could put it there. You can put it there. Doesn't really, I guess, doesn't really matter as far as height because we're going to call it something generic. Now, here's where students struggle. I get what you guys are saying. Okay? Trust me, I get it. The point we're putting it at isn't really the point we're putting it at. Like, we're going to call it something, comma, something, and those variables, by definition, variable, they vary, they change. They don't have to stay there. So as soon as you say in your mind, I'm making a right triangle, do you see how you've limited the triangle? You've limited it. No, you're an accountant. Sorry. No, it doesn't work that way. If I say you can do whatever you want, I give you flexibility to change. Does that mean anything to you?
Be honest with me. Sure.
So guess what? I say, hey, last point. I'm going to give you general numbers. You can be wherever you want. On your paper, you might have graphed it somewhere different than I did. That's okay. They're going to change. Does that make sense? Awesome. All right. Can I call them? Does either one of them have the coordinate of D?
No.
In it?
No, it doesn't. What do you mean? This one.
This point right here. Sorry. Does either one of the X or Y's have the letter D in it?
It's nowhere by the X's. It's no.
D is the X value of this point. This does not have that same X value. So we need new letters. The book uses, well, what do you guys want to use? I don't care. A and B, sure. A, comma, B. Could A be 0? Yes. If A is 0, you have a right triangle. True or false? True. Okay. If I say, hey, you can do whatever you want, okay, awesome. But you went to college for accounting, okay, narrowed it down. And then you took the test to be an accountant, passed, of course. And then you applied and got a job. Oh, you're an accountant. Ready? You can be whatever you want. Oh, look. A is 0. We find out for some other reason later on. A is 0. Oh, look. Okay. Now you're a right triangle. Do you see how you can't fix it? When I said you're looking at it backwards, you fixed it to be a right triangle first. You didn't allow it to have any flexibility. But if you put it there, it could be a right triangle. It could not be. Does that make any sense? That's the foundation of proof and understanding generalities and geometry. I know it's tough. Next. Oh, wait a minute. We're more specific now. Place an isosceles right triangle in a coordinate plane. Now we've narrowed it down a bit. Isosceles right triangle. Can you picture an isosceles right triangle? Can the hypotenuse ever be equal to the one of the legs?
No.
No. The hypotenuse is the longest side. So it's the two legs that are congruent. Now don't draw this. Hold on a second. Is that how you want to place this isosceles right triangle?
No.
On the coordinate plane?
You gotta make it easy and bring on 0.
Okay, but listen. If I place it this way on the coordinate plane,
Not like that.
and I want to find the length of the hypotenuse and the coordinates of its midpoint,
Yes.
maybe? I kind of like that the hypotenuse is here because I can count it, right? But how do I know? How would I know where this point goes? Good morning. Thank you. Tally?
Above the center of the hypotenuse, or like halfway.
Do you think so?
Yeah, I think so, because I don't know.
Oh, it's
I'm
a
not sure either.
midpoint in the middle. I agree.
Tally's got a good point. She thinks maybe find the length of here and put it right above. Levi?
You should put like the right angle on where the X and Y come together, because then you can just like count up 3 and go right 3.
Yeah, I think that's easier because here's the problem. I don't know how to draw these in at a right angle except for opposite reciprocal slopes. Like that's going to get kind of messy. But if I put it at the origin, I know the X and Y axis are right angles to each other. Do you agree? So I do think in that scenario, if we have the flexibility to place this thing on our own, that is going to be the easiest way to place this. Now, they used the letter K. You didn't have to. You could call it A or B. But whatever this is, 0, K, do you agree this length over here has to be K, 0? I'm going to get rid of these tick marks. They're kind of bothering me right now because we're not that far in the problem yet. Okay, just ignore them. Here's what we have so far in our picture. We placed a right triangle with its right angle at the origin, and the points 0, K and K, 0 have to be isosceles. The legs are congruent. Do you accept that? That 0, K, that length of that segment is the same length as K, 0. Awesome. So find the length of the hypotenuse. Find the length of the hypotenuse. How are we going to find the length of the hypotenuse? Good. How long is the leg? How long are the legs? K. K. The legs are K. The hypotenuse, which is called PQ, we have to use the distance formula. Tessa, what do you want to put in the first set of parentheses?
Honestly, I don't know.
You remember the distance formula, Tessa? I can help you out if you don't. It's where you subtract the x's and then subtract the y's and square them. So what's this point's x value? 0. What's this one? So we're going to do 0 minus k. And then we're going to do the y's. So what's this one's y value? Minus. Good. So P, Q. What's negative k squared? K squared, very good. If you forget, guys, if you forget something like that, especially when it goes to abstract, like if I said what's a negative 5 squared, most of you would say 25, right? If I say what's negative k squared, I don't know. It's negative k times negative k. When you square something, you multiply it times itself. A negative times a negative is a positive, and k times k is k squared. Plus k squared. What's k squared plus k squared?
2k squared.
Very good. Do you know how to simplify that radical?
No.
Bryce. Very close.
K.
There's some good games though. McKenna.
Never mind.
Anybody? This is tough.
4
I think I know it's
4
Is
K.
it square root of 2 times k?
Tyler. Nailed it.
Yes, Tyler.
It's k times the square root of 2.
How does that work?
1.
Thank you for asking. All right, ready? We did this earlier. What's the square root of 27?
3.
Okay, let's break it up. Ready?
Oh, that's
What does it break up into?
9, 3.
9 times 3. Ready? Hey guys, I need you to listen. This is still under the square root. We're going to be doing this a lot this year. It's the square root of 9 times 3, right?
Yeah.
Isn't 9 3 times 3?
Yes.
What is the rule? When you have a pair of numbers, you pull one out, right? Remember, isn't 3 times 3 really 9? And what's the square root of 9? 3. So it comes out as a 3 because the square root of 9 is 3. This is 9. 3 times 3 is 9. What's the square root of 9?
3.
3. What's the square root of 3? Ugly. I don't know. Leave it in there. 3 radical 3.
What if they're not all the same number?
Thank you. 5 times 7 times 7. I don't even know what number that was, but I don't care. We've already started in this step. We've already broken it down. What comes out?
How do you know it's 7 5?
7 radical 5. Because what's 7 times 7? It's 49 under the square root. When you take the square root of 49, you get a 7. Right? Back to the question.
What are we? So the 2 isn't squared. It's only the k.
It's a square root. It's not squared.
Oh, sorry.
Oh,
Yeah.
here.
Yeah.
Right, because
So that's why you
K
take the
squared
k out
plus-
and not the 2.
correct. So this is 2 times k times k. We have a pair of k's. What comes out? K radical 2. K times the square root of 2. Does it make sense now?
Yes.
All right, well,
No.
let's see if we answered the question. Find the length of the hypotenuse. Okay, it's 2 radical k. Nope. K radical 2. K radical 2. This is a very famous triangle. We're going to deal with it a lot later in the year. K radical 2. Really quick question for you. What if this point's over here at 10? 10 comma 0 and 0 comma 10. What's the length of the hypotenuse? Okay. Let's pretend this is 10. Let's pretend this is 10. What's the hypotenuse? 10 radical 2. K is 10. K is 10. 10 radical 2. What if K is 12? Hypotenuse? 12 radical 2. Now, don't forget, radical 2 is a number. Between what two whole numbers? Well, radical 1 is 1. Radical 2, radical 3. Radical 4 is 2. Radical 1, radical 2, radical 3, radical 4. Radical 1 is 1. Radical 4 is 2. So radical 2 and radical 3 are between 1 and 2. Do you agree with that? Type it in. Go ahead. Did you already do that? Radical 2, 1.41. Preston, you got this? Radical 2?
1.41.
1.41. Okay. So if this is 10 and I say 10 radical 2, that's one way to write it. Isn't 10 radical 2 10 times 1.41?
Yeah.
Isn't it 14.1?
Yeah.
So this hypotenuse in that situation would be 14.1. All right. These right triangles, they're used all the time. You have to trust me on that. I worked in construction for 10 years and through college and a little bit after in the summers. You use special right triangles like this all the time. Okay? What's that, Christiana? All right, next. Write a plan to prove that SO bisects angle PSR. SO bisects angle PSR. Wait a minute. How do we prove something bisects an angle? Say it cuts it in half, right? So we have to prove that it's cut in half.
Equal side.
Or we learned something called CPCTC. Hey guys, you'll be way further ahead. The people in here who listen, a lot of you just start complaining when I say stuff. The faster you accept it and say I need to use it, the better off you'll be. Levi.
Can't you just say that the two bottom points are -3 and 3 on the x-axis, and the bisector goes on the y-axis? So it's.
Is that true every time?
I mean, if it's on the y-axis and they're like the same or the opposite x, then yes.
We have to prove that. I think you're right. We have to prove it though. That it's true. All right. Given the coordinates of vertices POS and ROS. All right. Well, if it's asking you to prove that I don't know why this printed off like that. It's kind of weird. I couldn't get it any other way. I used the teacher's edition online, but that's just segment SO. It's segment SO there. All right. Do you agree? If I could prove the triangles are congruent, then all the rest of the parts of the triangle have to match up. So watch. If I could show that these angles are corresponding parts in congruent triangles, and they're congruent, then that segment must have bisected the bigger angle up here at S. Does that make sense? Let me say it one more time. If I can prove that this angle is congruent to this angle, then SO must have bisected PSR.
Yeah.
Make sense? All right. Well, and it just says write a plan. We're not actually doing a 2-column proof, okay? We're writing a plan. So this is kind of like what we call a paragraph proof. Why is PO congruent to RO? Well, how long are both of those segments? 3, right? That's from the picture. Those are congruent. Now, I say from drawing, but do you agree those cannot change? They didn't label them K, 0 and -K, 0. They called them -3, 0 and 3, 0. Yes? So they're fixed. What else? can we tell from the picture? See it? Preston? Yeah. Preston?
SO is congruent to SO.
SO, congruent to SO? Reflexive property. Are we there yet? Do we have SSS?
No,
SAS?
no,
ASA?
no.
AAS? HL? No. So what else do we need? Either pair of angles or a pair of sides?
Angle bisect, like definition of angle bisect.
But we're trying to prove that it bisects an angle. And so I would probably say, if we're trying to prove SO bisects this angle, then we can't say SO bisects this straight line down here. Do you agree with that? So we probably can't go with the angle argument. Christiana?
Oh, we're not doing angles?
I would probably not do angles.
Do we need to prove PS is congruent to PR?
Let's do that. Yeah, let's show that these last pairs of sides are congruent. And to do that, we have to use the distance formula. All right? So PS, 0 minus -3 squared plus 4 minus 0 squared. Get 9 plus 16 squared to 9 plus 16. Just a little warning for you. Square roots do not, there's a property. You cannot take the square root of each of these and then add them together. Order of operations, you have to do what's underneath the grouping symbol first. You have to actually add 9 and 16 first. Do you agree?
Mm-hmm.
You want me to show that? Or are you guys okay with that? What's 9 plus 16?
25.
And what's the square root of 25?
5.
5. What if you did it this way? Is this okay? Can you do this? What's the square root of 9?
3.
What's the square root of 16?
4.
What's 3 plus 4?
7.
Not 5. That does not work. Do not ever do that. You have to do what's under the parentheses. Parentheses, grouping symbol, square root first. Next, we're going to do SR. SR. 0 minus 3 squared plus 4 minus 0 squared. What's 0 minus 3?
-3.
What's -3 squared?
9.
So it's square root of 9 plus 16. Oh, look. 5. Square root of 5 or 5?
5.
5. 5. Oh, look. SSS. So PS was congruent to RS. And they were both man, this is glitching out, a length of 5. So triangle POS congruent to triangle ROS by SSS. So now there's 2 more steps. Aren't these angles right here? Aren't those the angles that go together in those 2 triangles? We didn't mention them in the proof, did we? But they have to go together, right? Angle PSO is congruent to angle RSO by CPCTC. And at this point, you could have said angle P and angle R are congruent, right? I mean, we could have said any of the rest of the angles are congruent, but why was it that pair? Well, that's the pair we're worried about because we want to show that SO bisects that angle up here. So because those are congruent, SO must bisect angle PSR. Why? Well, that's the definition of an angle bisector. A segment that cuts an angle into two congruent parts. Well, since the parts were congruent, it must have been a bisector. Does that make sense? We're going to wrap up 5-8 tomorrow. You have a couple problems for homework. All right. Please stay optimistic. I can always count on you. Yeah, Josh, I appreciate it.
So much.